If these materials are not removed, they can get into the compressor's moving parts and cause damage. From the filter, the clean oil flows to the oil cooler, which is a small heat exchanger. If the oil is allowed to overheat, it breaks down and loses its ability to lubricate. Cooling the oil prevents this from happening. The oil then flows to the compressor, where it lubricates bearings or other moving parts. The oil then flows back to the reservoir. The next components we'll look at are seals. Several types of seals can be used to prevent leakage inside a compressor and out of a compressor. A mechanical seal consists of a rotating element and a stationary element that can be used to form a seal between a rotating shaft and a stationary housing. A labyrinth seal consists of a series of ridges that create an intricate path that makes it difficult for leakage to get through the seal. This is a cutaway of part of a labyrinth seal. Both mechanical seals and labyrinth seals may be used with a seal oil system. Some compressors rely on a seal oil system to prevent gas from leaking out of the compressor casing along the shaft. The simplified seal oil system illustrated here includes a mechanical seal located around the shaft at the point where the shaft penetrates the compressor casing, and a labyrinth seal. The seal oil system also has a seal oil reservoir, which is divided into two compartments. The reservoir contains a strainer and an oil pump. The system also has a head tank and a check valve. During operation, the oil is pumped through an oil supply line and into this space around the shaft. The mechanical seal prevents the oil from leaking out of the compressor. The oil flows through the labyrinth seal and prevents gas from leaking out of the compressor along the shaft. The oil flows through the seal because the pressure of the oil is greater than the pressure of the gas in the compressor. The oil then flows back to the reservoir through an oil return line. As the oil comes in contact with the gas in the compressor, some of the gas is entrained in or carried along with the oil. The gas separates from the oil in one of the compartments of the oil reservoir. The gas rises up through the oil and returns to the compressor through a gas return line. The oil flows to the oil pump and is then returned to the head tank is used to supply oil to the seal if the pump fails. The check valve keeps the oil from the head tank from flowing down into the oil pump and forces it to flow through the seal. The head tank contains enough oil to allow the compressor to be shut down without a gas leak if the seal oil pump fails. The next components we'll look at are bearings. Two types of bearings used by most compressors are radial bearings and thrust bearings. Radial bearings support the compressor shaft. The bearings are lubricated to allow the shaft to rotate freely inside the casing. But the bearings prevent most radial movement, which is movement that's perpendicular to the shaft. Thrust bearings prevent axial movement, which is along the axis of the shaft. By allowing the shaft to rotate while keeping it in position inside the compressor, the bearings keep the impellers or blades from hitting the stationary parts and being damaged. In this part, we'll look at different devices commonly used with compressors. The devices we'll look at are drivers, couplings, aftercoolers, safety valves, and receivers. It's important for you to be familiar with these devices in order to understand the operation of a compressed gas system. Drivers are the devices that provide the power that is needed to operate compressors. Compressors are most commonly driven by electric motors, although in some cases you may find gas turbines or steam turbines used to drive compressors. Several types of devices are used to transfer power from a driver to a compressor. Three such devices are fixed couplings, variable speed couplings, and gear drives. A fixed coupling connects a driver shaft and a compressor shaft so that both rotate at the same speed. When a fixed coupling is used, the speed of the compressor can be changed by changing the speed of the driver. With a variable speed coupling, the driver can be operated at a constant speed, and the speed of the compressor can be changed using the coupling. A gear drive is another device that can be used to allow a compressor to rotate at a faster or slower speed than the compressor's driver. Another device that's important for the proper operation of a compressor is a gas cooler. Coolers are used to remove heat that's produced when gases are compressed. A compressor system often has a cooler that is located in the discharge of the compressor and is referred to as an aftercooler. The aftercooler shown here is a shell and tube heat exchanger. In this case, the compressed gas flows through the tubes in the aftercooler, and it is cooled by cooling water that flows around the tubes. Another essential device you should be familiar with is a safety valve. Safety valves are used to protect compressed gas systems from overpressurization. A safety valve opens to relieve excess pressure before the overpressure condition can cause personal injury or damage system equipment. The last device associated with a compressor we'll look at is a receiver. Basically, a receiver is a tank that is used to store compressed gas so that compressors don't have to operate continuously to compress gas. A receiver may also be used to store compressed gas for future use. In this topic, we looked at a variety of systems and devices that are commonly used with compressors. Now, try some practice questions that relate to this material. Radial bearings support the compressor shaft. The bearings are lubricated to allow the shaft to rotate freely inside the casing. But the bearings prevent most radial movement, which is movement that's perpendicular to the shaft. Another device that's important for the proper operation of a compressor is a gas cooler. Coolers are used to remove heat that's produced when gases are compressed. A compressor system often has a cooler that is located in the discharge of the compressor and is referred to as an aftercooler. The aftercooler shown here is a shell and tube heat exchanger. In this case, the compressed gas flows through the tubes in the aftercooler, and it is cooled by cooling water that flows around the tube.